So I think it's going to also be really worthwhile if we can do a little review on basic graphing skills. You're not going to be able to use graphing calculator on the exam, and so you've seen these things before, and I'm just going to do some really basic graphing problems and kind of remind you basically how everything works. So there are a few things that you just have to memorize. We've been over a few of these in class. So you need to know that a parabola, let me see, there's some tool here that helps me draw straight lines if I can. I think it's this. Okay, great. Alright. So you need to know the graph of y equals x squared. Looks like this. Okay, so this is sort of a basic shape. So y equals x squared, and then any kind of quadratic equation or degree 2 polynomial can be seen as sort of a transformation of this thing. So that's one of the basic shapes. Also, you should know what the hyperbola looks like. So the hyperbola is the graph of y equals 1 over x, and it looks like this, and we've already seen this in class a few times. Okay, so that's just a shape that you need to know, right? You need to know what the graph of, you need to be able to recognize the graph of a line, obviously, right? So lines, and we know that these graph as y equals mx plus b, and in this form m is the slope and b is the y-intercept. So the y-intercept is the place where the line touches the y-axis, so this is the point B on the y-axis. And you know what the slope equaling m means. If you go over by 1, then you have to go up by m. Okay, so that's how you graph a line based on its description. So let's keep going. What about the square root function? You need to know what the square root function looks like. Okay, so it starts here. It's infinitely steep for a second, then it kind of goes like this. You can kind of complete it as it's like a sideways parabola. Of course this is not really there, but that could help you draw the top part if you just realize that if you reflected it across the x-axis, it would just be the parabola turned right by 90 degrees. So this is the graph of y equals the square root of x. And of course this increases forever. You can see that if you put bigger and bigger numbers in here, then the output will be bigger and bigger. Right? So what else? What about the graph of y equals x cubed is another important one. So we should know that this is the shape y equals x cubed, right? Yeah, and so also this is sort of the shape of any odd degree polynomial. So we went over that in class. It takes a long time to sort of describe the end behavior of polynomials. We spent a lot of time on it in class, and I don't want to do it all right now. But you should know that if you have an odd degree polynomial, that its graph basically looks like x cubed, and so it may do various things close to the origin. And any even degree polynomial basically looks like x squared. It may also do some weird things near the origin. So even degree polynomials do the same things on both ends. And you need to know the graph of the exponential function. So the exponential function is going to start getting a lot more important in your life. It's a big star both in Calculus 1 and in Calculus 2. And of course you also need to know what the inverse of this function looks like, the natural log function. So this is what y equals ln of x looks like. And it crosses the x-axis here at 1. And as x goes to 0, it goes down to minus infinity. And of course, since these functions are inverses, they're reflections of each other across the diagonal. Can I remove that? Okay. So the diagonal would go like this, right? Wow, I love that straightening tool. So you can see they're kind of reflections of each other like that, right? So inverse functions always are reflections of each other across the diagonal. And this is the very special line y equals x, which will also come up a lot. So this is a line of a slope 1 with x-intercept 0, because it's like plus 0 is b, so it crosses the y-axis there at 0. Speaking of special cases of lines, I should remind you how you describe a horizontal line. So horizontal lines come up a lot in calculus, and the graph of or a horizontal line is always the graph of what we call a constant function. So if this is y equals 9, for example, it's going to be a horizontal line. And so any function that's just constant, like f of x equals c, where c is constant, graphs as a horizontal line. So there's nothing special about 9, right? So it's a special case of a line that you should be aware of. Another special case of a line is a vertical line. So kind of a weird thing about a vertical line is that it can't be written in the form y equals mx plus b, because what would m be? It's like m is either plus infinity or minus infinity. I'm not sure which one. This form of a line really doesn't make sense for vertical lines. And the way you have to describe a vertical line is just by saying x equals something. So here's a vertical line, and so this is going to be described by an equation like x equals 6, where this is 6. Okay, and that's because these are all the points in the plane. These are like, what are the coordinates of all the points on this line? They're like 6, comma, y, and it doesn't matter what y is, any y is fine, and so this equation describes this vertical line in that way. Another common graph that will come up over and over again is the graph of the circle. Oh, I lost my superpower. Control Z. Whoops. So let's remind ourselves how to graph a circle, right? Frequently we'll be looking at the unit circle. So the unit circle is the circle of radius 1, centered at the origin. So this is the unit circle. Okay, and what's the graph of this thing? You should really be aware. You're going to see x squared plus y squared equals something over and over again. So this is the graph of the equation x squared plus y squared equals 1. It's not a function, it's an equation. Why is it not a function? Because it doesn't pass the vertical line test. Remember the vertical line test? So if this were a function, then an x here would have to go to some unique destination, but here there are two choices of destination. That stops it from being a function. Frequently, in this equation describing a circle, you'll solve for y, and the positive solution is y equals the square root of 1 minus x squared. Okay, so you should have that in mind. And that's mostly the way in which a circle will come up. I mean, we could also talk about ellipses and circles with different radii centered at different places, etc. But that's really the important thing you need to know right now. So what else? Okay, so let's talk really quickly about some basic transformations. So I'm taking this from Diagnostic Test C in the textbook. Here's a question. It says, without using a calculator, make a rough sketch. So without a calculator, sketch the graph. Right? So let's do it. And so the first equation that is not just totally trivial is y equals 4 minus x squared. Okay. So now this involves one of those memorization things. Like one thing that you just have to know is that y equals x squared is a parabola, okay? So we're going to realize this shape by seeing how these extra symbols change this thing. So what it does to it really is it makes it negative and then it adds 4 to it. So what do each of those steps do? So if you take any function and you make it negative, what that does is reflect it across the x-axis. So this is what minus x squared looks like. Now this is adding 4, so what does that do? If you add anything to a function, what it does is push that shape up or down the y-axis by that amount. So what that plus 4 does is move this downward facing shape up here like this. Okay, so this is the basic shape, y equals 4 minus x squared. Now we could add some detail and figure out what these points are, and we can do that using what? This is a difference of squares, right? You might notice difference of squares is coming up over and over again. And you know, in various times in my life people have tried to teach me things and it seems so specific and dumb I thought I would never need to know them. But please trust me, if I say you need to know something, it's because I think it will, I know from teaching this course in the past and etc. that it really will help you do better. So there's a reason that you might not be able to see right now that you need to know these things. It's really, really important for you to understand the difference of squares. Right? I hope that message is clear now. So what does this say? This says that the two solutions here, or in other words, the x-intercepts, one of them corresponds here. So this is the x value 2 making this function 0. So that's x equals 2, and this one is x equals minus 2. Okay, so we found the x-intercepts and the y-intercepts. That's a pretty good picture. Maybe we should do one more transformation if there's a fast, easy one. Yeah, so here's a good one. What about y equals x minus 2 cubed plus 3, alright? So now to do this you just have to remember one of the basic shapes that you've memorized, and the basic shape that you need to know is the shape of x cubed. Okay. So one thing about x cubed is that it gets totally flat here at the origin, right? And okay, so this is just x cubed, and now what's happening is we're doing several things. So first, x gets replaced with x minus 2. So what does that do to a function when you replace the variable with x minus 2? So now what this does is 2 is going to be like the origin was before. So what that did is push it across the x-axis, sort of like this. Alright, so it pushed it to the right on the x-axis because now 2 is like the origin was before. And now plus 3 is going to work kind of the way that it did before. This is the way it always works. If you take the graph of a function and then look at the graph of the same function plus some number, it just changes, it just pushes it up or down the y-axis. So we're going to go up now by 3. Okay, by the way, this is the point 2. And this is sort of the final picture. So it's going to go sort of completely flat here, down like this. Okay. So maybe just to add a little bit of extra detail, I might wonder what the y-intercept is and what this x-intercept is. And this function is still simple enough that we can figure these things out. So what is the y-intercept going to be? That's always really easy to find because it's just f of 0. So what happens when you plug 0 in for x here? You get 2 cubed, actually negative 2 cubed, so that becomes minus 8. And then plus 3 is equal to minus 5. Alright, and that tells me that my picture is not quite right, okay? And just so I don't have to make another correction, let me find the x-intercept at the same time. So the x-intercept is going to be what makes all this stuff 0. So I have to solve an equation. I have to solve the equation x minus 2 cubed plus 3 equals 0. So let me do that. Move the 3 over to the right, and I have x minus 2 cubed equals minus 3. Now I can take the cube root of both sides, and I get x minus 2 is equal to the cube root of minus 3, and move 2 over, and bring this minus sign out, which you can because it's an odd root, and plus 2, okay? And so I have to ask myself, is this going to be a positive or a negative number? That's really what I want to know for the sake of my picture. So what's the cube root of 3? I guess the important thing is it less than 2? So 2 cubed is 8, so that's a lot bigger than 3. So the cube root of 3 is going to have to be, it's going to be small. Alright, so this is going to be a positive number. So when I correct my picture, I've learned two things. I've learned that the y-intercept is actually going to be negative 5, which is down here, and I've learned that the x-intercept is actually a small positive number. And oops. So let me make both of those. Actually, let's just graph the thing over here, and then you won't have to deal with my bad handwriting. So the function we're graphing is x minus 2 cubed, and of course you can't do this on the exam, but you can use it to correct your guesses while you're studying. So there it is. Okay, so this is a better picture than I could possibly draw by hand. I hope it's thick enough for you to see. By the way, you know, on YouTube you can adjust the resolution of the video in the bottom right hand corner of the video window, and you might want to change it to high definition so you can see the handwriting better and stuff. Alright, so I'm going to let that be the end of, actually I wanted to stop, but I'm going to do one more thing. I'm going to review graphing a function that's defined by cases. So this is also from the diagnostic quiz. So consider the function f of x equals 1 minus x squared if x is less than or equal to 0, and x is equal to 2x plus 1 if x is greater than 0. Alright, so you know, graphing a function defined by cases isn't really any harder than graphing an ordinary function. So what is this saying? It's saying to the left of 0, including 0, the shape is just going to be this. So negative x squared is downward facing parabola. This pushes it up by 1. Okay, so don't just let your eyes glaze over. You really need to know that. You need to be able to do it yourself. And so here is 1, okay? Except this is only true up to 0. So actually I shouldn't have drawn this part, because this part is defined by the other case. Alright, so what does it do on this other part? So on this other part it's 2x plus 1. So that is a line, and this is b, and this is m. So b is the y-intercept, so this is going to be a continuous function because the second part picks up right where the first one left off, right? And now it goes up with a slope of 2. And you can draw the straight line like this. Okay. So yeah, alright. So now I'm done with graphing. Remember, this is a continuous function. That means there are no holes. And that's it for this part. I'm going to stop the video.